Hi guys, in this video we're going to continue with qualitative graphs, but we're also going to be analyzing what graphs are saying, which goes hand in hand with what we just did in our last lesson. So we kind of used the phrases decreasing and increasing previously, but we're going to really focus on which part of the graphs are increasing and decreasing here. And then anytime that it's staying flat or horizontal, that's a constant interval. So A right here, it is falling during the stretch. So as I read from left to right, it is decreasing. So this is a decreasing interval. B, it's staying completely flat, so that is a constant interval. From B on, so this is the C segment, as I read from left to right, it is rising. So this is an increasing interval. D is falling, so that's a decreasing. Then E is flat, it's staying the same, so it's constant. Okay, so we are going to look at these three graphs and we're going to match them to one of these scenarios. So here in 2, I have a person blows up a balloon with a steady airstream. So we are comparing volume over time. So as you blow up a balloon, the volume is increasing, but they said they're doing it with a steady airstream. So it should be increasing gradually with this constant rate right here. So B is going to go with 2. A person blows up a balloon steadily and then lets it deflate. Okay, so the volume of the balloon is increasing and then it's going to go back to 0 once they let it deflate. So A would match up with scenario 3. And process of elimination, C is going to go with 4, but let's match up the scenario with the graph. So a person blows up a balloon slowly at first and then uses more and more air. So they start slow and then blow more and more air so that volume increases a little bit quicker. All right, same idea on this one. A person leaves home, drives through town, then on the highway, and then finally stops at a rest area. So we are measuring distance from home over time. Okay? All right, so this person is getting further and further away from home. So they're driving through town, so they're going kind of slower through town. Then on the highway, so they're going to get further away faster. And then they're going to stop at a rest area and they're going to stay at that place. So they're still getting further and further away from home, but we can kind of analyze that. A person leaves from home, drives to the other end of town, buys groceries, then returns home. So their distance from home increases. Then they stay at the store, so the distance stays the same, and then they're going to come back home. So the distance should come back to 0. And the last one is a person walks to a friend's house or she stays overnight. So it goes, and then that distance away from home stays the same. All right, so 5 is going to go with A. So they're getting further and further away from home through town, so it's a little less steep. Then it gets steeper because they're getting further away faster when they're on the highway, and then they're stopped at that rest area. B is going to go with the person who stays overnight at a friend's house because they go away from home and then they stay at that house. So that distance away from home stays the same. This is the person going to the store, goes to the store, is at the store, and then returns home. All right, last 2 here, we are going to draw some graphs to go with these scenarios. So number 8, we are going to sketch a graph for the given situation. Marty is skydiving. At first, he's falling rapidly, then releases his parachute until he reaches the ground. And notice it says, make sure to label your axes. So we have options. We could... pretty much all of them are going to have time on the x-axis, but we could measure his speed. We could measure his distance above ground. I'm probably going to do that one. So you guys can choose, though. You don't have to do the same one. Distance above ground. All right, so he starts in the plane, right, and jumps out, and then he's falling rapidly. So I'm going closer and closer to the ground. Release the parachute. So if you guys have seen the parachute, it usually actually pulls you back up for a second. So when they release the parachute, pretty quickly it's going to pull you back up, but just briefly. And then you're going to fall, but you're going to come a lot more steady and slow to the ground. So this part of the graph should be a lot steeper than this part because you're falling rapidly. You might even want to make it steeper than I made it. Falling rapidly, parachute kind of comes back, and then it should be very gradual coming back to the ground. All right, Sylvie puts ice cubes in her soup to cool it down before eating it. Okay, so this one to me kind of pops out that we should use temperature over time. So temperature of the soup. Or you could do temperature of the ice cubes, honestly, either one. So I'm going to do of the soup. So the soup starts really hot, and then it's going to just cool down over time. The ice cubes cool it off a little bit faster. So the ice cubes cool it off kind of fast, but the temperature might not drop very much. So that might come a couple degrees, and then it's going to kind of gradually come down. So I'm not doing it as steep here. And then it's eventually going to never go to 0. So if I think about temperature, if it's in a room, the lowest temperature it's going to get is the same as its surrounding temperature. So let's say whatever this temperature is, that's my room temperature. So it's actually never going to go to 0. All right, so that would be a graph that would kind of match the temperature of the soup over time. And that's it for interpreting graphs, just kind of some more with those qualitative graphs, situations, and matching those up.